This is Physics 7, May 27, 2026. I'm going to share my screen here and let's take a look at, we're almost over, right? And here you go. The exam, final exam is on 8th of June. The final exam week starts on Tuesday, June 2nd. June 2nd, okay? And according to my syllabus, we should meet on Monday as well, unless I am incorrect, right? Are you folks having any other class on Monday through LA Harbor? Because we have, the exam starts on Tuesday, the 2nd of June, right? I suspect that the college gives the Monday off, but I'm not sure about that. Do you folks have any other classes at LA Harbor on Monday?
No.
Huh? You don't know?
No.
No? No? Okay. Okay, so maybe we shouldn't meet on Monday. I'm gonna inquire that with my chair. Okay, so unless I tell you, if I don't say anything, we're not meeting on Monday. Okay, let's do this way. If I don't say anything, we don't meet on Monday. But I suspect that we shouldn't be meeting on Monday, right? Because the the exams start. Here you go. Let's take a look. The final exams start on Tuesday. Let's take a look here. And Tuesday is going to be the 2nd, right? Here you go. I look all over the catalog to find out whether we meet on Monday or not. I didn't find anything about it. And last day to, let's see, Memorial Day, Genocide Remembrance. Let's take a look here. Here you go. Okay, yeah, Tuesday, June 2nd through June 8th. Our final exam is going to be on June 8th, which is the last day of the finals. How do we find that out? Well, okay, just look right in here, right? Our classes are meeting Monday and Wednesday. So it should be right in here. We meet Monday and Wednesday. Let's see here. What's going on? 9:40, okay? Yeah, here you go. We meet between 9:10 and 11:10, so it's right in here. Consequently, our exam is going to be on June 8th. Start time will be 9:40. Well, let's see. Oh, no, sorry. Here you go. Our classes start at 9:40. Okay. Consequently, the final exam is going to be June 8th, Tuesday. No, Monday is a Monday. Between 9:10 and 11:10. Between 9:10 and 11:10. Yeah, I have everything right in here. Okay, and then I'm going to put a question mark here because I still do not know whether we have to meet or not. I'm going to inquire that with my chair. And so all that's left is to do lab 8. Okay, well, I'm not going to cover any, I'm not going to do any lecture because we finish special relativity. And all you're left with is lab number 8. Let's take a look at lab number 8. And also what I want to do, here you go. insert, page break, May 27, 2026. That is a Wednesday. Week number 16, meeting number 28. Week number 16, meeting number 28. One more student trying to join here. And the situation is the following, unless I tell you otherwise, I tell you otherwise, we are not meeting on Monday, June 1st. I want to check with my chair, right? Whether we have to meet on June 1st or not. Okay, that's the first point here. And 2, I started correcting the report for lab number 5, right? Lab number 5. So watch closely. It's correction in the next couple of days. Okay, so it's final correction, right? It's final correction the next couple of days. Let's take a look at the other lab reports. We can also write in here, not this one here that I wanna go. Let's see here how things are going. May 27th, okay. Lab number 7 is due today. Lab number 6 was due a week ago, almost a week ago, right? And I'll let you know when lab number 8 is gonna be due. So I'll be working on correction of lab number 5 and lab number 6, okay? The reports for lab number 5 and 6, and just watch out for the final correction that I'm going to post, that I'm going to upload to your group folder and post in the grade, in your lab grade. Any questions? Okay, so that's what I want to tell you. And let's take a look now at lab number 8. Yeah, Kimberly, you want to ask a question?
Yes, for the final exam, what would it cover all the chapters or certain ones?
Yeah, all chapters. Yeah, good question. And how do I usually do the final exam, right? Let me write that down here for you. And let's see, everything. See that? Everything, final exam, everything. And what else you have to know? Note, see that the third exam cover up to chapter 26, right? So chapter 27 didn't show up in any of the partial exams. nor the labs 5, 6, 7, and 8. Okay, so what's going to happen? There will be a heavier weight on the chapters, and labs that didn't show up in the previous exam. Okay, I'm going to write that down here for you. So there you go. For the final exam, the final exam covers all material, all the material taught in the lecture. However, you should expect 30 to 50% of the questions to be concentrated on chapter 27, right, which is relativity. On the material, there you go, on the material that did not show up in the partial exams. And what was this material? Chapter 27 and the reports for labs 5 through 8, right? 5 through 8. So yeah, 5 through 8. So let's write it down in the syllabus. There's no space here to write in here, unfortunately. But you got the idea, right?
Yes, thank you.
So you should expect 30 to 50% of the questions to be concentrated on the material that didn't show up in the partial exam, chapter 27, and the reports for lab 5 through 8. That's what you should expect. Okay, so let's take a look at there's no more questions. Let's do the lab. LA for spring. Right in here, lab raw data. Let's see this one here. Let's take a look at this. Okay, that's the diode. I don't think I want to do the diode. Let's see what lab number 9 is all about. That's odd. Okay, that's the capacitor. Okay. Let's do the diode. Okay. Something different. Let me close this one as well. Today is the 27. Okay, I'm gonna stop sharing my screen. Yeah, we're going to do this one here. One more student joining us. This lab is, let me go, today's lab. Now I can start sharing the screen again. But contains a diode instead of a regular resistor. Okay, so this lab is very similar to the other one that we did for the light bulb, flashlight bulb. Okay, this lab is very similar to the following labs. It's not just the flashlight bulb, but there is this. I'm going to document here for you. Lab 8, the diode. That is the flashlight, very similar to the following labs. Lab 7. Lab 7, the flashlight bulb. Flashlight bulb. And lab 5. Yeah, which is the 2 resistors in series. Okay, 2 resistors in series. Let's put it here in series. And lab 5, 2 resistors in series. In the case of today's lab, we add a diode. Let's see. We put a resistor and a diode in series in the circuit. We didn't cover the diode in the lecture, but you will understand how it works, okay? How it works is a very simple device, one of the basic devices in electricity and electronics, okay? Just recall that there are 5 basic devices in electricity and electronics. Oops, here you go. The first one, the simplest of all, that was the one that was first invented, was the capacitor. The other one is the resistor. The other one is the inductor, which is just a coil of wire. The other one that I told you is the transistor. And the final one is the diode, electrical diode. And by the way, not only we have electrical diodes out there, right? But we also have mechanical diodes, okay? The mechanical diodes is easier to see because we know how a mechanical device works. Okay, I'm gonna give you an example. that is a mechanical device that allows you. Let me stop sharing so you can understand. There is a mechanical device that allows you to couple two of those devices. Right? Think about a ring and another device here that can open, just like a ring as well, okay? But it's something that can open, but it would open only if it's impacted in one direction only. We have devices like that out there, okay? So if you have a ring coming to crash with this other device here, which is my mechanical diode, the mechanical diode would open and would let it grip the other one. Okay, but if but if this ring impacts the diode on the other direction, the diode remain closed and doesn't allow the ring to escape it. Okay, this is an example of a mechanical diode. The mechanical diode is a device that lets another mechanical device move in one direction but not in the other. Okay, that's what the diode does. That's what the function of a diode is to let something to move in one direction, but not in the other. In the case of a mechanical diode, you do have this movement from my right to my left, but not from my left to my right, because the guy is now locked into place. That's the basic idea of a mechanical diode. The electrical diode is a similar idea. The electrical diode is a device that lets current to flow in only one direction. Okay? So here you go. What does the diode do? It allows electrical current to flow. I need to start sharing the screen again, right? To flow in only one direction. That's what a diode does. It does have a resistance, okay? With one important difference, comma, it does not obey Ohm's law, okay? It is not an ohmic device, just like the flashlight bulb, right? So now we can take a look at those different devices that we covered in the lab. 1, 2, 3. Let's see. Okay, so here you go. Devices, resistor. Okay, flashlight bulb and diode. Ohm's law, ohmic device, ohmic device. Yes, the resistor is an ohmic device. The flashlight bulb is not an ohmic device, and the diode is not an ohmic device. And by ohmic device, I mean if they obey the Ohm's law, if they obey the Ohm's law, V equal to Ri. Current flow in both directions. Right? The resistor, yes, allow current to flow in both directions. The flashlight bulb allows the current to flow in both directions, but not the diode. So that's the distinction between those three important devices that we find out there. Let me here organize this table. Okay, someone is trying to come in. That's what you have to remember about the diode. Good. Oops. A little bit more, right? No. Should be no and no, right? And that's what lab 8 is all about. Let's see if I have the notes for lab 8 here. Uh, yeah, it doesn't look like I have the notes for lab 8 here. Let me try some other here. In 5, let's try here. 2024, spring P07 quiz, no syllabus. Yep, we got lab number 8 in 2000. I did lab number 8, 2024. Let's get the notes for 2024. And those are the notes for 2024. Every time that I teach this course, I create my notes from scratch, right? So I have all, let's see, I have all these notes. They're almost the same, but sometimes almost, but not 100% the same. Yeah, here you go. That's the notes for the lab number 8. Okay. And I don't need that anymore. But I'm going to need the notes for 2026 right here. Okay, so let's go here. Insert, page break. Here we go. So don't forget, we have an exam for on. I should write that down here too, right? We have an exam. We have a final exam, on June 8th from 9:10 to 11:10 a.m. 2 hours long. Okay, and let's go back to our page break here. Oh, here you go. Huh. What did I do here? Okay, I put too many. Good. Now it's the way I want. So let's summarize what I just said before, right? So we have ohmic elements, just like regular resistors, and we have non-ohmic elements. The flashlight bulb is one of them, and another one is the diode. This is the electrical diode. In the lecture, we did not cover ohmic elements. We covered only, we did not cover non elements, but we do cover non-ohmic elements in the lab, okay? So we perform these experiments to expose the student to the idea that there are certain elements that do not obey Ohm's law, okay? And again, Ohm's law is V equal to Ri. If you change the current in a circuit, and the circuit has a ohmic device in there, the resistance of the circuit is not going to show up. Okay, the resistance of the circuit is going to be constant. It's not going to vary. Okay. Constant for a given resistor. For a given ohmic resistor, let's put it this way, ohmic resistor. Okay, the flashlight and the diode do not obey the above law, but it obeys something similar. The flashlight bulb and the diode do not obey this law, but it does obey something similar, a similar relation. And the similar relation is going to be something like that, okay? The resistance of the device is going to be a function of the voltage and the current. And instead of having V over I, it's actually going to be delta V over delta I. Okay, that would be the ohmic relation for those non-ohmic devices. That would be the Ohm's law, right, for those non-ohmic device. And as I mentioned before, the diode is a semiconductor device that transmits currents in a single direction. It does not let current flow in the other direction, right? In the other direction. In the other direction. And that's where I should copy and paste that table that I created right here. Right here. Like that. And let me now upload your spreadsheet. Google Drive. Physics 7. Okay. So let me get my spreadsheets here. What we're going to do here, this lab is going to be very similar. It's kind of a repetition what we did for the flashlight bulb and the two resistors in a circuit. few resistors in a circuit. Group 4, group 5. You have your spreadsheet there. Group 6, group 7, group 8, group 9, group 10, group 11, group 12, group 13, group 14, group 15, group 16, group 17, group 18, and group 19. Please confirm if you don't have, if you didn't get your spreadsheet, please let me know, but it looks like I uploaded everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. So go ahead, download the spreadsheet for this lab. Which is in your group folder. The spreadsheet for this lab to the hard drive, which is in your group folder, okay? And let's take a look. Also, let's get the PowerPoint slide. Lab correction, illustration, lab slides, right here. Let's see. Okay. I don't have it here, but I might have it elsewhere. Let's see. Download the lab report, lab slides. Huh. That's odd. Let's see here. Yeah. Now I'm struggling here in finding out my. Let me pause the recording. Remind me to turn it back on, okay? Let's see. Oh, yeah. Okay, here you go. I hope we didn't miss too much stuff, all right? Sorry for this overlook. Okay, so what I'm doing here, I'm comparing the circuit diagrams of the other two labs that we did with the circuit diagram of the diode lab that we're going to do today. Yeah, let's see here. Yeah, it's getting too small. Let's put them in the vertical direction. Otherwise, I'm not going to be able to see it. Right? Lab number 8. I'll put it here. Here we go. That's lab number 7. And then we have lab number 8. Where is my... Ah, you miss it. Okay, here you go. No, I didn't miss it. It's just the Word document that's behaving oddly today. Now I can increase in size. So you can. And the other one, when I mean that those three labs are very similar, that's because we have two elements and both elements are connected in series. That's what I mean by those three labs are similar because the two elements are connected in series. Okay, it just happens that we have one of the two elements are different, right? One is a regular resistor, the other is a flashlight bulb, and the other is a diode. Copy only. Go. This other one here. And I'm going to do like that. I'm going to keep this guy in the same page as the other. Insert page break. Yep. Lab 5. Just for comparison purposes. It's always good to have those comparisons because it allows you to see that there is a logic behind all those labs, right? The only thing that changes in this case are one of the elements, the light bulb here, and finally, maybe I can even shrink it to keep everything in the same page and look nicer. And make it look nicer. Here you go. Like lab number 8. Let's see, shrink it. And now I'm going to put another page break here. Good. Okay, so here you go. Let's zoom out a little bit. So you can see everything. Design, let's see, where is the zoom? Design. View, must be in view. Oh my goodness. Okay, here goes. Zoom. Zoom out a little bit. And now you can see all the three circuits separately when we do not need this table anymore, right? We go. Okay, I don't need that either. And what I want to do, I want to take a little break so you can digest a little bit this material, right? And give some thought about those three different devices. Lab number, let's see here. Yeah, lab number 5. Good. We have 5, 6, 5, 7, and 8. I'm gonna put here break. That's 1050.
Professor,
Yeah,
I have a question.
yes, go ahead.
For lab number 8, some of the cells have something different on for my lab.
Really? Which group number are you?
6.
6. Let's take a look what's going on here. So lab reports. Let's see here. Lab slides. Labs raw data. Lab 8. Yeah, group number 6, right? Let's see if there is something that shouldn't be there. What was the problem that you saw in there?
You see where it says hashtag div? Yeah,
Yeah,
that section.
That's common. That's normal. I will cover that. There's nothing wrong with that. Okay. But I'm gonna tell you what does it mean, what it means. Okay.
Oh,
Okay.
okay. Thank you.
Okay. So let's have our break now, right? It's 10:50 right now. We have a break until 11:05, and I see you in 15 minutes. I am back, and let's go continue here with our notes. What? Let's go. The equipment is similar than the other one that similar to the other ones that we saw in the previous lab. Resistance of resistance large enough to produce a maximum current of 30 milliamps. A digital multimeter, an LED, proto board, power supply, right? And then cables. And what we do, we measure the resistance of the resistor with the DMM. Connect the resistor and the LED in series using the proto board. You already should know how the proto board looks like, right? Pick up. The proto board looks just like something like that with a bunch of holes here where we can connect the resistor and the LED. Connect the power supply in series with the LED and the resistor. Set the multimeter to measure voltage. And then we perform the measurements. That's the light bulb. Let me close this one. This other one here is the resistor in series. I'm going to close this one. We want to concentrate on this one right here. Okay, so here we go. The DMM, we connect the DMM to measure the voltage throughout the whole circuit. And that represents the V total. Okay, V total in your spreadsheet. The V sub is the voltage that the power supply shows in its screen. Then what will it do? Take the measurements, right? We vary the voltage here, take our measurements. Then we invert the polarity here and take what's going to happen when we invert the polarity. Remember that I told you that the LED does not allow the current to flow in a given direction. So when we have negative voltage here, okay, okay, the total doesn't change, right? The total doesn't change. What's going to change is when we put the current. Okay, what's going to change is going to be the current. See the current here, document this zero, okay? So when we invert the voltage, we get no current flowing through the circuit. Because there is no current flowing through the circuit, the voltage across the resistor, which is V1, right, is going to be zero as well. 0, 0, 0, okay? But the LED will have to make up for the total power supply because we must have conservation of energy. If the resistor is not burning any energy whatsoever, all the energy that's provided by the power supply should be consumed by the LED. Okay? And that's exactly what's happening here. This voltage is almost the same as this other voltage. Oh, this voltage here of the diode is almost the same as the voltage here of the power supply. But not here, right? Voltage of the diode plus the voltage of the resistor must be equal to the voltage of the power supply. And that's what we have here. And let's take a look here. I'm gonna, those are all measurements. Yeah, those are all measurements. Let me highlight like that, right? Measurements. And those are results. Different. Those are results. So we go. So we are measuring the total voltage, right? And now we are going to measure the voltage across the resistor 1. That's exactly V1 that you see right in here. The measurements across V1. And then you invert the polarity and you get V1 equal to 0, just like I mentioned before, because the current is 0. V equal to Ri, right? If I is equal to 0, V must be 0 as well. And all the voltage is consumed here in the LED. And then you repeat the measurement for the diode only. That's VD. Okay? Hello, that's VD right in here. Provided the voltage is in the direction of the diode, right? That the diode allows the current to flow. So the VD plus V1 must be equal to V sub. And that's what I have right here. Okay, VD plus V1 for conservation of energy. And the same applies to the rest here, right? Whether it's positive or negative. The summation. Okay, so here go V1 and then the final measurement. The final measurement is that for the current. We connect the multimeter in series with the whole circuit and take the current measurements, the measurement of the current. That's how the circuit diagram looks like. And when we invert the polarity, the current should be 0. Okay, and that's exactly what we get. Those are measurements that can be done in real life, okay? Here you go, right here. Didn't I highlight that? Let's see here. There's something. Okay, this one that I want. Okay. Positive, right? Current. Current in the direction of the allowable direction of the LED, and current 0 because the LED doesn't let the current to flow when we invert the polarity of the power supply. Now, what this division by 0 is all about, right? Someone asked that, right? Who was that? Who asked that? Was, let's see, was a girl, right? But I don't remember her name. Was that Kimberly, right? It was you, Kimberly, that asked that? Why we're getting division by 0, right?
Yes.
Yeah, it was you, right? Why are we getting division by 0, right? Because I'm doing, the V of the diode divided by the current, right? If the current is 0, right? I'm kind of calculating the resistance of the diode just by using Ohm's law. You can see that right in here, the resistance is around 200. Here's 300, 400, 600, 1,000. Notice that as I decrease the voltage applied, the current, the resistance of the LED itself increases. And then when I invert the polarity of the power supply, since no current is flowing, what does it mean? It means that the resistance of the LED is going to be a very large number. A number divided by zero. A number divided by zero is infinity, right? That's why we're getting this division by zero. Divided by zero. Okay? We're dividing a non-zero number by a zero number. That's why we're getting that. So that's correct. That's what is supposed to be happening. So what are we going to do? Now what really matters, right? What you should do. I want you, one, plot V1 along the y-axis and I along the x-axis. Plot VD, let's see, and I, right? Plot VD along the y-axis and I along the x-axis. That's what you have to do. Let's take a look how it's gonna look like. V1 and I, yeah. Insert chart. Okay, so you can see that whenever the current is in the proper direction, the voltage behaves according to Ohm's law, but only because we're plotting the voltage of the resistor, right? If we go ahead and get a trend line for this graph, we are going to get that the slope must coincide with the resistance of the resistor. So let's see if it does coincide. I'm getting 1020. 1020, there's something wrong here. Let's see what's going on here. V1. Mm-hmm. $92 only. Huh? Let's see. What am I? Looks like I'm doing something wrong here. Let's plot just this one. Insert, insert, insert. Right here. Right. Current trend line. Yeah, I'm getting 1012 here. Why is not? Yeah, for some reason it's not. Well, I'll have to look in more detail what's happening here. Okay, for the resistor, I was expecting that this slope was going to be the same as that of the resistor, but not that is not what we are getting. But what's most important here? Let me just erase this graph. Is to plot the VD versus the current, the voltage across the diode. That's the most, and then you're going to see it's not going to be, and actually, let's see. This one, for a diode, we usually plot all the way around, okay? Instead of, it's not VD along the y-axis, we do all the way around. Plot VD along the x-axis and I along the y-axis. That's the common way that we do. Okay, and then I have to invert, right? How do I invert? I do the select data, edit. G replaces I, and I replaces G. G replaces I, and I replaces G. And now you will be able to appreciate, let's see, here we go. Yeah, now we got it. That's how, don't forget, we have I along the vertical direction and V, D along the horizontal direction. Depending on the voltage, the voltage goes just like that. It increases absurdly from negative to a given value. Okay. Again, here's the current 0, right? And here is the voltage increases to very large, not the current increases to very large values from a given applied voltage. There is a little bit of a slope here. It's not easy to see, but there is, okay? I can even change, let's see here. It's a little bit difficult to see it, but there is a little bit of a slope. You can see from the V, because the V is changing, right? Let's see if I can get a better look at this value. Let's see, instead of -12, so you can see the abrupt increase. We are going to put 1 here. Yeah, now we start to see the increase, right? It's not a straight line. It's more like a parabolic. And let's see, I'm going to put 1 point, let's try 1.5. Yeah, we can see it. And then this should go, let's see, 1.7, maybe. Yeah. Do you see how it increases? It's kind of a parabolic behavior. Okay. In this scale, we can see that increase more clearly. That should be 155. Yeah, oh, no, 155 was too much. 152, maybe. 1, 2, 3, 4, 5. Yeah, now I'm looking at everything. But don't forget, I want you to display this graph here, okay? And 2, that's gonna be 2. And we can compare this graph to what is displayed in the literature. Let's take a look here. We can go to Google and we can inquire about I versus V graph for a diode. Okay. Let's Google search. Okay, here you go, exactly what we have, right? Here you go. See that? 0 current here, and suddenly the value increases up to a certain point. That's, yeah, what's that? Later, yeah. That's for a regular resistor, right? Here you go. Non-ohmic resistor. This is for our flashlight bulb. And this is for our diodes. The current is 0 up to a certain point, and then there is a minimum potential where the current starts to flow. Okay, every diode has this behavior. And here is another type of device, okay, resistance, and so on. But you have to concentrate on that. So what you see here is the same as you see right here. Okay, it's just in a different scale. Okay, so that's the only graph you have to plot. And then you have to work on the units, right? There is no CL here for this case. You don't have to worry about CL. And any questions about that? I'm gonna let you work on this, right on this spreadsheet right now. And then very soon I'm going to start asking questions to see how you're doing there, okay? So let me get my roster. This is my roster lecture lab. Okay, I have everything here. So what I want to do, let's show here. This one, not this one, it's this one here that I want, okay? Don't forget VD along the x-axis. That's how we usually plot the graph for a diode. We put the V along the x-axis. Okay. You don't need to do this one. You don't need to do this one. Plot VD along, and don't forget, fill up the units. Display the correct significant figures. There is no CL. For this lab. What I want to do, let's go, let's take a little earlier break, right? Break, and in this meantime, you can start working on, yeah, 11:30 a.m. to 11:45 a.m. So whenever I return from the break, I'm gonna check with you if you're having any problems. Okay. So I see you in the next 15 minutes. I'm back here. Now let's go back to the other graph that I was doing, right? When you plot V1 against I, you are supposed to get a straight line with a slope equal to the resistance, right? That's because across the resistor is an ohmic device, so the resistor obeys Ohm law. But then when I put the trend line of this equation, oh, we still get a straight line. The problem is the slope, is the value of the slope, okay? The problem is the value of the slope that's giving me 1,020 when it was supposed to give me 92. So there's something wrong here. That's for lab number 6, by the way. This problem is with lab number 6. Okay, so what's wrong here, right? Why the slope doesn't match the resistor value? Okay, the slope doesn't match the resistor value because the students who collect this data didn't log the current properly. Okay, they log like 8 times 10 to minus 3, right? 6 times. They put too many zeros in there. If whoever have this problem, group number 6 definitely has this problem, you will need to cut down 1 zero only from this data, and then you will be able to get data that is consistent with Ohm's law. At least group number 6 is going to have this problem. Maybe there's another group out there. Now I'm getting 102. That's much closer to 92. That 10%, yeah, it's a 10% difference. Okay. I don't have this problem with group number 1. Let's see. The values. Let's take a look. Yeah, here you go. For group number 1, see, I got the proper slope, the proper value of the slope. Note, see that the current value 8 times 10 to minus 2, right? Here, it was 8 times 10 to minus 3. So the reason that group number 6, the spreadsheet of group number 6 was displaying me a slope that was not matching the resistance just because of those values of the current. Okay, you might want group number 6, you might want to fix that in your spreadsheet. And let's take a look at the other. Here you go, group number 2. And I don't want to do this one. Let's see. Let me erase that because I don't want to change this one. Let me erase this one here. I want to use a different document. Yeah, I want to use this one. Let's take a look at group number 3, right? Let's see if we're getting the right slope for the V1I. Insert, chart, here you go. Add trend line, display equation chart. Yeah, again, I'm getting 93.6368, right? So the problem definitely there was a problem with the data of group number 6. And maybe there's another group there that has the same problem. So go ahead and plot 2 graphs for this lab. Let's see, plot VD along the X. Yeah, plot V1 along the Y-axis and I along the X-axis. There you go. Check if the slope matches the value of the resistor. Okay. That's what you have to do. For group 6, make sure you cut 1 zero out of the values of the current. Okay. Instead of 8 times 10 to minus 3, should be 8 times 10 to minus 2, and so on. That's for group 6. And there might be another group in there. If you are this group, please let me know. Now let's go one by one. Today is the 27th. We're right here. Okay, now let's see. Download. Okay, Oni, did you download the spreadsheet? Is Oni there? Yep, Oni's here.
Yes, I'm here. I wasn't able to download the spreadsheet just yet. I am going to do it right after. I do.
Alright.
I
Okay,
do what I need to do right now. But um, I have a question. You said we're on lab 8. Um, what happened to lab 7? Because you said that it was only supposed to be 7. Now it's 8.
let's take a look at the syllabus, right? Here you go. Lab 7 was the flashlight bulb. We did lab 7 before exam 3. Okay, and this is lab 8. Okay, that so we did lab 7 back in May 13th. Then we have the exam, right?
I remember you gave us extra time for lab 6, which you said is due May 22nd. And then after that, we were just talking about lab 6. We didn't talk about lab 7.
Yeah, take a look here at the schedule. Okay, here you go. Here's the schedule, and it's due. Lab 7 is due today. We did, like I said, we did lab 7 2 weeks ago. Okay, if you look at the syllabus, you're supposed to turn in lab 7 before the day that we start the other lab. But if you need more time, let me know. Okay.
Okay, I will let you know, and I definitely need more time.
All right.
All right, thank you.
Okay. Now next one here. Mirage is not here. Susan Acosta, are you there, Susan? Yeah, Susan seems to be here, right?
I'm here.
Okay. Did you download the spreadsheet, Susan?
Yes.
Okay. Did you plot graph 1, right? The
Yes.
graphs, both
Mhm.
graphs? Okay.
Yes.
How was the slope of the first graph? Does it match your numerical value of your resistor?
Yes, it's closely. I have
Uh-huh.
91 I have 87 for my value resistor 1, and then in the graph it shows 91.
91. Okay, that's good. Okay, and what you gotta, let's put just graph here and start working on did you start working on the units already?
Yes.
Did you finish?
Yes, I did.
Oh, you did finish the units. Okay, and what about the sig figs?
I finished it, but I'm still kind of confused.
Uh-huh. What's that
Mm,
that you need to know?
we don't have to do the zero ones, right?
Oh yeah, the zeros, you don't have to worry about significant figures of the zeros. Yeah,
Okay, okay.
that's
That's
right.
the only one.
Uh-huh. That's the only one, right? So you
Mm-hmm.
finished the significant figures. Okay, good.
Yeah. Yes.
So next is Evelyn Ayala. Is Evelyn Ayala here? No, Evelyn is not here. Next is Christina. Let's see. Let's go to Arian, right? Since videos. Arian, did you download the spreadsheet?
Yes, I downloaded the spreadsheet. I finished the units and sig figs.
Uh-huh. What about
Uh,
what about the graphs?
the graph one, I'm stuck where you have to like switch the axis because
Uh-huh.
my VD doesn't go to x-axis. I don't know how to do it.
Oh yeah, let's do it together, right? Let's do it together. It's something similar to what we did at the beginning of the course. Okay, so here you go. If you gotta highlight I, you have to highlight VD, right? Even better.
Yes.
There's more than one way of doing that. Let's do this other way here. You know, you go ahead and you copy this column, okay, for VD, and you paste right in here on the right side. But when you paste, make sure you right click and you paste just the numeric values. Okay, like that. That's one way of doing that. And you do the same for the I. Copy. But then you paste the I on the right side of VD. That's the trick. You gotta paste it on the right side of VD, right? And don't forget, paste the values only. Do not paste the format. So Excel has this option, this pasting option, which is a nice thing. And now you have the values in the proper order. When you have an order like that, you know, this column ends up in the x-axis and this other column ends up in the y-axis, okay? So you highlight, insert, that's one way. And then you get the graph. That's one way, okay?
Oh, actually, that worked.
Yeah. The other way, you know, the other way you can do too is, you know, highlight I, highlight VD, right? Insert, plot, you get the graph here, and now you have to switch the axis. How do you switch the axis? You switch the axis by click one of the data points. All the data points are highlighted. Now, right click, and then you select data. That's the other option. What else? What else do we have to do? We gotta edit. You gotta edit the numeric values of those those data points. Edit. So, and then when you come here, notice that you have see this X value, G, right? G column. Okay, and see these Y values, I column. You have to switch. What is G becomes I. Okay, and what's I becomes G. When you do something like that, you invert the axis. You go, what's I become G. Click OK. And now click OK. And now you got the graph in the proper format. Okay? Two different
Okay,
ways
thank you.
of doing the same thing. That's Arian. Let's go for Carlos. Carlos Gallardo. Carlos Gallardo, see. Gallardo. Right in here. Is Carlos there? Looks like he's away from his computer, right? Okay, I'm going to put, let's see how I'm going to do that. Yeah, I'm going to put a star. I'm going to put one here. Next is Jason. Jason Surveillon. Are you there, Jason?
Yes.
Okay, so let's go here. One, did you download the spreadsheet?
Yes, I downloaded it.
Okay, did you plot the graphs?
I haven't done so yet because I'm using a different computer because my computer is at the repair shop.
Okay, do you think you can do the graphs before the end of the lab today?
Uh, it's because this computer doesn't have Excel. It only has Google Sheets.
Okay. Can you get access to another computer before the end of this class, of this lab meeting?
I could try looking for one real quick.
Okay. Okay, so
Okay,
I'll get back to you once you
sure.
get the computer, okay?
Mm-hmm.
Okay, so next one here is Juan Torres Arellano. Are you there, Juan? Juan Torres Arellano. I don't hear from Juan. Let's see. I'm gonna put a star here under one name. Next one is Kimberly. Kimberly, are you there?
Yeah, I'm here.
Okay, good. Let's take a look here. Your group number 6, right, Kimberly? So
Yeah.
yeah. So did you fix that the problem with the current?
Yeah, I did. I just wanted to make sure that my value is good. So removing one of the zeros, my slope became 102.08.
Yeah, 102.08.
Uh-huh.
Good. And what's the value of your resistor?
It is 0.9997.
No, I'm asking the resistor that's the R square, right?
Yeah.
The resistor is this value right in here.
Oh, that part.
Yeah, see R1 here?
92.
Yeah, 92. 92 is very close to 102, right?
Yeah.
Okay, it's kind of a 10% difference. We could get a better thing, but we cannot do better than that. Okay, so you did the first graph. What about the second graph?
Yeah, I got it.
Okay, it looks just like we talked about, right? So let's see, Kimberly, group number 6. Let's see here. Oh yeah, right in here. So you download the graphs. You did download the spreadsheet. Did the graphs. Did you work on the units already?
Yes.
Okay. What about the sig figs?
Yes.
Okay. Any other questions? Do you have any questions?
No.
Okay, good. So let's go for the next one. Kimberly, Onia, I talked to Onia already. Princess.
Yep.
Okay, good. So let's see, Princess, your group number, Princess, which group are you?
Group 6.
Okay, so you are with Kimberly. Okay, good.
Yeah.
So here you go. Did you download the spreadsheet?
Yes.
Okay, did you plot out the graphs? 2 graphs.
Yes.
Okay, did you fix the problem with the current there in your spreadsheet?
Yeah, Kimberly and I were fixing that together. So
Okay,
yeah, I
good.
did fix it.
Okay, so you also work with the units, right? You also did the
Yeah.
units and the
Yeah.
sig fix. So basically,
Yeah.
you're done, right? Basically, you're
Yeah.
done. There's nothing
Yeah.
else to here. That's
Mm-hmm.
good. Thank you. Now, next one is Queen Castaneda. Let's see. She left a message here for me. I was able to download and doing the graph so far right now. My computer like not sure if you called or not. Okay, good. So Queen, I'm calling you right now, Queen. So let's see here, Queen. Your group number 4. So okay, you downloaded the graph. Let's see. Okay, so you plotted both graphs, right, Queen? Are you there? Oh, okay. Doing one. Okay, you're doing. Did you do both graphs or just one of them? One and working on the second. Okay, so I'm gonna put that you're working in the graphs. You finished the first one. The first graph. Did you compare the slope with the resistor value? Not yet. Okay. Okay, so I'll go get back to you. Next one is Susan Acosta. Right in here. Okay, so I already talked to you, right, Susan? And so the way I see it, you finish everything, Susan. Do you have any question?
No, I don't.
Did you compare the slope of the first graph with the resistor value?
Yes.
Okay, is that close enough?
Yes.
Okay, that's good. So let's recycle here. It is 12:06. Okay, so we have 44 more minutes to go. The next one I want to talk to is, okay. So Oni, did you manage to download your spreadsheet?
I'm going to do that a little bit later because I am doing something else right now.
Okay.
Um,
Okay.
yeah.
Okay, so let's move on to someone else. Let's see. Navid. Let's look at Navid. Arian, right? Arian. Okay, Arian, you're done. You finish. Did you finish the graphs, by the way, Arian?
Yeah, I finished the graph. Yeah.
Okay. How does the
I'm
slope?
working on the second one.
Okay. How does the slope of the first graph compare with the resistor value?
Oh, I didn't get the. I forgot.
Yeah. Take a look at the value of the slope, and then click in. Let's see here. Let me put you are working on that. Click in the cell where the resistor value is and read the number there. Okay, right in here. In this case, the value is 8838, but in your case, it's gonna be a different group number, right?
Yeah, I'm at group 10.
Yeah, you're group 10, right? Okay. So just click this cell here and read on the top what's going to be the exact value of the resistor. Let's see. Next one is Jason. Let's see.
Yes.
Yeah. 1 minute, Jason. Let me get here.
Mm-hmm.
Jason survey. Okay, good. So you were working the graphs, right? Last time?
Yes.
Did you finish
I
them?
was still looking for a computer.
Oh, okay. Looking for a
Yeah.
computer. Okay.
Mm-hmm.
So whenever you get a computer, let me know, right? Let me know. Looking
Sure.
for a computer. Okay. Next is going to be Juan Torres. Juan Torres. Are you there, Juan? Looks like Juan's too far away from his computer. Kimberly, it looks like you finished everything, right, Kimberly? Let me see here. Yeah, Kimberly finished everything, right?
Yes.
Okay, any questions?
No.
Okay. Next, only Princess. Let's see, Princess, you are working with Kimberly, right? No. Yeah, Princess is working with Kimberly, so Princess is done as well. Queen Castaneda, let's see here. Queen Castaneda. Let me look for Queen. Yeah, here at the top. Okay, Queen was working in the grass. Are you there, Queen? Oh yeah, here you go. I'm working on the second, right? Yeah. Okay, so it looks like she's still working at the second graph. Okay, good. So anybody else? Susan must be done, right? Yeah, Susan finished everything. Okay, I want to give you a little bit more of time, and so you can advance there with your spreadsheet. Whenever you're ready, ask me a question, okay? We have 40 more minutes to go. Those who finished the spreadsheet, you can leave. And let me give you a deadline here to turn in the spreadsheet. Okay, I'm back here. I gotta talk to my internet provider. It goes, I keep on having this problem here with the internet connection, but hopefully it didn't take too long, right? And since today is the last meeting, I'm going to ask you to turn in this spreadsheet. Okay, the exam is on the 8th. Okay, today's